Welcome back to a demonstration video of transient stability analysis using PSSE. Now that we have performed the transient stability simulation, the next step is to review the results. Now in PSSE we have two methods to review the results of our simulation or transient stability. In this video we are going to check or review the results with the help of method number 1. With method number 1 you can use is Plotbook. So how do we use Plotbook? For using Plotbook you simply go to open. From here you select channel output file and open your channel output file. Our Plotbook is going to get opened like this, an empty Plotbook with the data in the plot data tab. So you go to plot data tab, from here you select plus sign and you see the file 3-phase underscore fault underscore gen bus underscore 100 millisecond has been opened. So now when you expand this file, all the channels we have written in our system are available here. What did we do? We selected two channels for the angle of generator number 1 and the angle of my infinite bus, that was load bus number 2. But now the data stored in these are basically absolute value. But what do we want to see? We want to see the angle of generator 1 with respect to my infinite bus. So how can we do that? It is simple. We can create a function. So what are we going to create? We are going to create a function by right click on the function and add function, and my function will be simply a minus b. What do I want is I want to see the angle of generator 1 with respect to generator number 2 or my infinite bus. So here in this case a will be generator 1, angle of generator 1, b will be my infinite bus angle. So when I press OK and expand this, now my function has been created. So to use this function, I will right click on my first channel, copy function, and right click on a paste channel. Similarly for the reference, which is my infinite bus, I'm going to right click on copy function, and in B I'm going to select, and when I simply drag and drop, and there you go. So after 10 seconds, what are we having? We initially, my relative angle with respect to my infinite bus was 15 degree. As soon as the fault occurred on the system, the angle increased to almost 36-37 degrees, and then it came back, but it started oscillating. But see that my first oscillation and the second oscillation, they are dying down. So although I have some oscillation in the system, but they are dying down. So my system is almost stable. It is going to take more time. Why it is taking more time? Because it does not have enough damping power. Without enough damping power, you will see this one. So for system to be stable more quickly, you need more damping torque. When the damping torque is not, or damping power is not available in the system, you will see these kind of oscillation. But my system did not go out of step. Now let's see what happened to the generators. For selecting the generators, I will just right click on the side and insert a new page. Let us see what happened on the bus where the fault was initiated. So this. So you see my initial voltages were 1 per unit. Voltages here are on the y-axis shown in per unit, and on x-axis time is shown in form of second. So up to 1 second my voltages were stable at 1 second. As soon as the fault was initiated onto the system, the voltages dropped to 0, exactly 0, because we used bolted fault. And after 100 millisecond fault was cleared, so my voltages returned back to its pre-fault level, and then they were adjusted and everything seems to be okay. What about the far end? At the far end or at the infinite bus, the voltage dip will be less. The reason is because for the far end bus or the infinite bus, there were two transmission lines in between. Due to these transmission lines, the voltage drop at the infinite bus will be less than the generator bus. So if I just drag and drop this on this line, see Here in this case, this green curve, my voltages are not exactly 0, they are a little bit above 0. The reason is the impedance of the transmission lines, which saved the infinite bus for voltages to go to 0. Now what about the transmission lines? So I insert a new page. Let us see here. So this is my bus number, this power from circuit number 1 to 2. If I drag and drop this, so what is happening? My initial power was 25 megawatt on circuit number 1. As soon as the fault came, voltages dropped to 0. So due to this voltage drop to 0, what happened? P is equal to VI. My V became 0. Due to this 0, my power became 0. So this is exactly what you are seeing here. The power became 0. But as soon as the fault was cleared, we tripped the line. So that is why the voltages or the power on this is remaining 0. But if we see the second line between bus 1 to 2 circuit number 2, if I drag and drop in on the same, see, in this case the power is once again 25 volt. When the voltages became 0, power became 0. As soon as the voltages returned back to its pre-fault condition, or in the post-fault scenario, when the voltage is recovered, the power doubled, almost doubled on my system, because I had two identical circuits. When I will trip one circuit, the whole power of the generator is going to be shifted onto the second circuit, and this is exactly what we are seeing. After some oscillations, when the P electrical is trying to become equal to P mechanical, I am seeing these oscillations. But as soon as this P electrical becomes equal to P mechanical, I see a reduction in oscillations.